All right, so first off, right off the bat, what I'd like you to do, guys, on your calculators, can you just do 5 divided by 0? Some of you may already know what's going to happen, but... And mine's not any more powerful than yours, and I still get an error because you can't divide by 0. All right, so I get an error. So here's what we call any fraction with 0 in the denominator. Denominator, the bottom. Any fraction with 0 in the denominator, we call an undefined fraction. Undefined. I'm going to make this very, very clear before you walk out the door, and I'm sorry if it gets annoying. I do not care what's in the numerator. Do not care. I only care about the denominator, and if there's a 0 there, it's undefined. You could have whatever you want in the numerator. A 5, a 6, an x squared, a happy face. I don't care. Okay, it's all about the denominator. Can't have a 0 in there. All right? So today what you're going to be doing is you're going to be finding different values of x that make a fraction undefined. All right, so for this first one here, very, very basic, extremely basic. What value of x is going to make that fraction undefined? Well, what makes an undefined fraction when the denominator is 0? So there's only one option I have in there, and that's 0. All right, so it's 0. Any other number I plug in there is fine. Even a negative number, even a fraction, that's fine. But I can't have 0 in there. All right, I cannot have 0. And then we start getting a little bit more crazy. On example 2, right below it, I have 10 over x plus 7. What number could I plug in for x that would make it undefined? And don't say 0. Don't say 0, because here's why. If you plug in 0, 0 plus 7, 7. That's not undefined. I need a number where the entire denominator is going to be 0. What's up, Caitlin? -7. Everyone agree with her? Okay, let's just say you couldn't, that didn't come to you right away. Is there a way I can figure it out? Yes. You take the denominator, which is x plus 7, and what makes a fraction undefined when that denominator is? Watch, equal to 0. That's all you have to do to find out if it's where it's undefined. And then, yes, you move the 7 over, and just like Caitlin told us, you do get -7. Everyone all right there? Because a lot of the times you're just not going to be able to look at it and go, oh, it's that number. Right? You're going to have to set it equal to 0 and do some work. All right, let's go up to 3. Like 3. I don't know. I don't know if I could even do this. Just looking at that denominator and trying to pick a value of y that would make the entire denominator 0. I don't think I could do that. So that's why I'm going to do 5y plus 11 equals 0. When is that denominator equal to 0? Hey, before you solve it, why didn't I touch y minus 3? Why didn't I touch y minus 3? I'm not looking at the numerator when you talk to me about undefined fractions. All right, I'm not looking at the numerator. All right, let's solve it. You move the 11 over, right? This is no big deal. And divide by 5, y equals -11 fifths. Do not care about the numerator. Everyone, yeah, well, Matt, what do you got there? So what are you trying to tell me? My method's not good enough? Well, no, I like your method, but I'm just saying, can you use like uncontested process? Sure, if that's the way you want. If that's the way you and your flow back there want. All right, it's a strong flow game you got going. All right, strong flow game. Everybody good? All right, the toughest ones are coming up right now in example 4. What makes this fraction undefined? Look what's in the denominator. Yikes. All right, I can't, and now going back to Matt's point here, in all seriousness, there's no multiple choice. All right, so I can't use that to my advantage, but here we go. This is what we did all last unit. We solved these when they were equal to 0. Everyone's got an x squared, right? What's your a value here? 1, and it's a trinomial. So anybody want to tell me what type of numbers I'm looking for here? Don't tell me the numbers. I'm looking for 2 numbers that do what here? Let's go, Caitlin. Two numbers that multiply to your C value, negative 14, and add to that B value of 5. Here, we're going back again. I told you guys, bad news for some of you. We're still factoring. All right, I'll let you guys think about that. I'll select a random young one here in a second to see if they can find any numbers that multiply to negative 14 but add to 5. There's not many out there that multiply to 14. Let's go 9. 7 and 2. She's got the numbers. Now I just need the signage for it. Go. We're done. Unless you want your other arm in a sling. Too harsh? Too harsh? Good. 16. Plus 7 minus 2. Good. I joke because I care, Emma. Okay. All right, two answers now. Y equals. So if y was equal to negative 7, that would be undefined. It would be 0 in the denominator. Or you could also have y equal to 2. So either choice, if I plugged into the denominator, would give me an undefined fraction. Denominator equal to 0. That's about, well, I couldn't say, I don't want to say as tough as it's going to get. The factoring is going to get a little tougher, but all good. What do you got, Marco? What? Because I could tell on that either you have a question or you just always have that goofy look. There's two values that make it undefined. There are two y values that if I plugged in would make 0 here. It's negative 7 and 2. There's no rejecting anything here. You're going to get two answers sometimes. Good? Yes, Emma.
Wait, do you know that you're going to get two answers because there's a 2 over the y or there's the y value?
The highest exponent's 2?
Yeah.
That rule's never changing. Okay, that rule's never changing. All right, here we go. Let's try out these here. What value of x make these fractions undefined? 3 is going to be a little tough, so we're going to have to go over that a little slower than the first two. All right, so somebody explain to me what you're doing on number 1 to find the value. 9, what are you doing on number 1 to find the value of x that makes it undefined? Good. I am paying 0 attention to those numerators. And I'm moving the 4 and dividing by 2. What do you guys have as the value of x on this one? 13? Whenever you're ready. 2, yep. Only value. Everybody good so far? Again, number 2, just look at the denominator. X squared minus 8x plus 15. What value of x is going to make that equal to 0? Okay, got to do a little work. What's the a value on this one? 1, it's a trinomial, so you can do your whole multiply add game with yourself. Multiply to 15, add to negative 8. What do you got for me? And I'm going through this a little bit quicker because we spent a couple units on this now. 7, what do you got? Negative 5. Negative 3, yep. Those are my numbers. $22. Hi, Fiona. What are my two x values that would make this fraction undefined? X equals 5 and x equals 3. All right, before I get to this one here, number 3, just let me make a quick comment. I'm showing by factoring because for me, in time's sake, it's the quickest way. I also want to remind you, there's 2 other ways you could solve for x from last unit. What are those 2 other ways? You complete the square, move the 15 over and complete the square, or you could bust out quadratic formula. I'm just throwing that out there, everybody. Okay, you can factor. I'm just showing factoring because it's a little bit quicker. All right, but you could also complete the square and use quadratic formula if your factoring game was a D+ level. Okay, if your factoring game's not that strong. All right, we ready for this beast? 3. We have not factored like this in forever. And again, I can't, you could complete the square, you could use quadratic formula, whatever you prefer. I probably wouldn't recommend completing the square here. Anybody know why I say that? A value is not 1. And if I divide everything by 2, is that going to be pretty here? Nope, not going to be pretty here either. So I'd maybe avoid completing the square, so quadratic formula, or what we're going to do now, factor it. All right, let's review this thing. 3 terms, and what's the A value? 2, so I can't go numbers that multiply to -15 and add to -1. I can't do that when the A value is not 1. So now everyone remember a little grouping here. Dig deep here, dig deep. What was the first step in the grouping process? Multiply A and C. So everyone ready? 2 times -15. -30, yes. Now you take this trinomial, 2x squared, and you break that middle term up into 2 terms. Remember the blanks? -15. That stays the same. What are you guys looking for now to fill into those blanks? Multiplies to -30, but we'll add to -1. Multiplies to -30, but we'll add to -1. Start thinking about numbers that multiply to -30, but it'll add up to -1 when I plop them in there. Any thoughts? 2? Not here. Lucky you guys. 7? 5 and -6. Kid is a beast back there. So -6x and plus 5x. Everyone agree? And now I group them. What do we want to take out of that first grouping? 17, what do you want to take out of the first grouping? 2x, what are you left with? Okay, there we go. And remember, grouping, you want what's in the parentheses to be the same, so hopefully somebody can take out GCF in the next one to be left with x minus 3. Next grouping, what do you want me to take out? 9, a 5, and what are you left with when you take out a 5? X minus 3. All right, finish grouping. Finish it. 27. Finish it. 2x plus 5 is in one parenthesis, and in the other one, x minus 3. Remember, we got to solve here, so it's still equal to 0. Because remember, you get values of x out. Now you can draw your line down. X minus 3 equals 0. 2x plus 5 equals 0. Solve for x. Solve for x. Yes. Sure. So you guys get 3, and what's your other value? Negative 2.5. If you left it negative 5 halves, that's fine too, or negative 2.5 doesn't bother me. Yep. And sign out too on the sheet right here. The sheet right in front of you, And there's a pen on the desk. Everyone good? Emma, go ahead. I'm ready.
For number 1, since you said you could do it like solving number ways, could you use GCF?
Sure. Go ahead. What would you take out? And what are you left with?
X minus 2.
That 2, as we remember, does nothing because there's no variable. So what do? Set x minus 2 equal to 0. What's your value of x? There you go. There's your answer. Guys, listen to me. Hey. If this is too much, use quadratic formula. Okay? If this is too much to remember, just get out quadratic formula, store A, B, and C in there, and get after it like we did last unit. Okay? That's fine. All right. I'm not going to critique you on the way you do it. All right. If this is too much for you, get out quadratic formula and solve that way. Marco. Is there an echo in here? Because yes, I went over that. Yes, it's okay. You should be. Other questions? Okay, I am going to do 2 of the homework problems with you. So can you please go to number 11 and 12? Okay, let me just pause. What's the denominator? Still go through. This has nothing to do with radicals yet. What's the denominator here? So x squared minus 20 equals 0. How many terms are there? 2 terms. You're going to start thinking to yourself, well, maybe I can factor here. Maybe I can factor. Maybe I can factor. Can't. Is 20 a perfect square? So this is not different to 2 perfect squares at all. So you cannot factor this. You legitimately cannot factor. But I'm still going to solve for x. I want to get x by itself. How do I move the 20 over? Add it over. Go ahead. Let's go. Let's add it over. X squared equals 20. You guys know how to get rid of a squared, right? Take the square root. Don't touch your calculator because it's worthless right now. Okay, so x equals, but remember what happens when you take the square root of something, you get the plus or minus version. So I'm just going to write plus or minus square root of 20. I said your calculator was useless because the directions say leave your answer in simplest radical form, which means no decimals. It's got to have a radical in your answer. And I'm about to show you how to simplify a radical right now. Okay, so we're going off in a totally new direction. I'm going to show you how to simplify a radical. Okay, everybody good? We ready to go? Are you okay on this point? Setting it equal to 0. You can't factor it, so I moved the 20 over and took the square root. Okay, do you know what a perfect square is? Somebody just start shouting out numbers that are perfect squares. 16, 4, 9, 81, 64, 144. Okay, we're good. We get it, right? We get it. All right? So if you start listing off some perfect squares for me. 1, 4, 9, 16, 25, 36, 49, da 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 da. Okay, and you don't need to memorize them. Anybody know how I get 4? 2, 2. 2 squared. 3 squared, 4 squared, 5 squared. You don't need to memorize them. That's how these numbers are generated. Here's what, did you guys do this or no? You did? You got to this one? Really? Anybody else? Okay, well, here you go. You're gonna get a detailed explanation now. What you need right now, your first job, is to find the biggest one of these perfect squares that goes into 20. The biggest one, and it's got to go in evenly. The biggest one that goes into 20 evenly, up here. You decide. I hear people saying 16, but 16 doesn't go into 20 evenly. It's got to go in evenly with no remainder. So everyone agree, it's 4. Okay, so now what I end up doing here to this radical is I'm going to break it up into 2 separate ones. When I simplify it, 2 separate ones. Focus in here. This is brand new for some of you. Let's go. Underneath the first one is the biggest perfect square you guys chose, which was? Any idea what should go into the next one if I need to multiply it and get 20? Biggest perfect square, whatever multiplies to the number I needed. We're almost done. We're almost done. Plus or minus, anybody? Square root of 4? Square root of 4. 2, and the square root of 5 just comes along for the ride. That right here is in simplest radical form. A radical broken down as much as possible. Go ahead, Tom. What do you mean 2.5? What do you, where's the 0.5 coming from? No, it's not. Square root of 5 is a long decimal. Yeah, yep. So we're going to leave it like that. Everyone okay? Okay, that one doesn't make you great, so let's go to this one right here, number 12. Denominator, again, we're looking for when it's undefined, so x squared minus 45 equals 0. Is 45 a perfect square? 45 a perfect square? So this is not difference of two perfect squares. If this was listen guys, if this was a 25, a 9, a 16, I just factor it using difference of two perfect squares. But since it's not, I can't factor it. So I move the 45 over. X squared equals 45. Take the square root of both sides. So x is going to be equal to the plus or minus version of square root of 45. All right, let's see if we can break this down with less help from me now. So you got your perfect squares, your simplest radical form. So I break it up into two radicals right now. Don't yell anything out. Choose the biggest perfect square that goes into 45 evenly. It's got to go in evenly, so don't tell me it's 36. The biggest one up there, and it's got to be the biggest one. Don't do the first one you come across. It's got to be the biggest one. Anybody finding the biggest one up there? Cat? Everyone agree? 9? Okay. There's no other perfect squares that go into it other than 9. And what should go into this one then? 5, because 9 times 5 gives you the 45. And once you find the numbers, now you're on easy street. Square root of 9 is 3. So just write a 3, no radical 3, just 3. And the radical 5 comes right along. All right. Okay, Hannah, then Marco. Go ahead. Excellent question. Let me give you one that always happens too. 48. Anybody have a perfect square that goes into 48? Okay, it is 16, but a lot of people are going to say 4 because they hit 4 first and it goes in. They're like, oh, I won. But there's actually a bigger one, which is 16. So what happens if you plugged in 4? You ready? What should go into this one then? 4 times what gives you 48? Okay, 12. So you say the answer should be 2 radical 12, right? Is there a perfect square that goes into 12? What is it? 4 goes into 12, right? So that means if you can, whatever's left in your underneath the radical, a perfect square shouldn't be able to go into it if you pick the biggest one. Okay? I don't want to go into what would I do from, because I would have to break that down now too. Okay, and that's a little bit ahead of where I want to get to. We'll get to it eventually, but that's what happens. That's how you can check if you pick the biggest perfect square. You look at, let's just take a look. We had 5 underneath, right? Can you think of a perfect square that goes into 5 other than 1? Nope, so you did pick the highest one to begin with. Good? Anyone else? Questions, comments? Marco. Meaning here you go. Here's what I mean by evenly. 45 and we pick 9, right? Oop, I don't want that. 45 and we pick 9, right? Got 5. Let's say you pick 36. Oh, look at all that garbage at the end here. That means it doesn't go in evenly. Okay, that's what I mean by goes in evenly. Okay? Okay, 2 things before I let you get going on the assignment. One is, and you may see it right away, you're going to start seeing some Regents review problems on the homework. 1 or 2 a night. Do not skip them. Do not skip them. Try them out the best possible way for you. Second thing, on my answer key on Aspen, I did this on purpose. You're probably just going to see answers. So if I see answers on your homework, you're not going to get credit for it because I know you just copied it. And as you guys see, you got to show some work or you can't get the answer that way. All right, so I need work to get full credit for the homework. Check your answers still on Aspen, though. Check your answers. Bring any questions tomorrow with you. All right, go ahead, get started. You got plenty of time. You might be able to get through all of them. Call me over if any of the factoring becomes an issue with you or if the Regents questions become an issue with you.